most of the stuff I know that you guys have seen. Most of the stuff I know that this isn't going to be too crazy, but I want to show you how everything works together. For example, if I have 3 non-collinear points connected by line segments, that's triangle, just in case you're wondering. If I say this is angle A, B, and C, we'll just make it real simple. What do those 3 angles have to add up to equal? 180 degrees. Again, something you guys all knew. It's been common knowledge for a very, very, very long time. So what we call that is, it's called the triangle sum. Triangle sum theorem or whatever, I don't know. Basically means 3 angles in a triangle add up to equal 180. Again, dun dun dun, not groundbreaking, earth-shattering, or anything like that. It is something that each and every single one of you guys has probably some familiarity with, I hope. I know it's new to you because we just learned what a triangle was. If you need paper, I got plenty in the back, or you might have some too, because I don't want you to forget what a triangle is. There was no passive aggressive, sarcasm thrown to that at all, was it? Now, excuse me. When we're working with triangle sums, basically, it's just a matter of adding up your angles. Okay. One of the things I do want to introduce with this is things that you may or may not have worked with in the past, ratios. And what happens sometimes with triangles, especially in this textbook likes to use ratios to show how angles work with each other a lot. Whether it's just saying 2 angles are in the ratio of something that are supplementary, 2 angles have a ratio of something that are complementary, so on and so on. They could say 3 angles in a triangle have a ratio of 2 to 3 to 4. Find the angles. Find their measures. Okay. And that's usually the look I get. What happens here is we're going to use the textbooks like to set up ratios far more than what they used to. And it's not that it's very difficult, but I want you to remember what a ratio means. When we're talking about ratios, it means that we're comparing, each one of the angles then has some common value. So what we're trying to do here is that we're trying to figure out what is the common value that they all have. We know that all the angles have to add up to equal how much? 180, and there are how many angles in a triangle? I forgot, there's 3. So what happens a lot of times when you see the word ratios or are in an extended ratio, that's another way sometimes they phrase it. That just means that there's some common value that each one of those share. When you don't know what a common value is, what do you give it? A variable, right? Yeah, you just give it an x, right? So all this means is 2x plus 3x plus 4x has to add up to equal how much? So, like I said, it may be new to you as far as how to read that problem. They have a common ratio. They are in the extended ratio. It can be worded either way. When you see that, it just means take those numbers, put an x next to it. 2x plus 3x plus 4x. Correct. Yes, ma'am. Because we're talking about the 3 angles in a triangle. So what's 2x, 3x, and 4x add up to equal? 9x. Divide it out and you get 1. So again, mathing here isn't going to be difficult at all. It's how you set it up in terms of some of the vocabulary. And I've been saying this a lot this semester. The math isn't any more difficult than anything you've done so far in your academic careers. It's just putting it together with the vocab that sometimes takes a minute or 2 to understand. Now, the one thing it did say was find the measures of each of the angles. If you now know the common ratio, what do you do with that common ratio with those other parts? Find the numbers. So you're just substituting it 2 times 20, 3 times 20, and then 4 times 20. And you get, well, yeah, they'll all add to 180, very good, but what's 40, 60, and 80? Okay. I just wasn't sure if we had done a ratio setup one yet. And it works anytime you see angles are in a ratio. Angles are in a ratio, this happens. Then you just set it up that way. And it'll always work. If it says two angles have a ratio or have a common ratio and they're complementary, both the two angles have to have to equal. 90, good. Yeah, it's just using the vocab. Okay. So I wanted to show you that one first before we got too far. The other thing that we do, let's see, let's go back to that. I go back to my triangle. If I go back to the triangle, you actually have interior angles and you have what are called exterior angles. Exterior angles, this might be the new part. Exterior angles are angles that are on the outside. These guys are, what's that? Oh, yeah? Okay, cool. The exterior angles are on the outside of a triangle. An exterior angle and an interior angle create a what? A line, good. So exterior plus interior always equals how much? 180. Okay, very good. So we go back to the idea, or I can do this. Do this over 1 second. Define it. Exterior angle. Angle on the outside. It creates a line with interior angle. I'm trying to think of an easy way to write it out. That's about as easy as I can make it. And then obviously, if you want to take it a step further, you know that if it creates a line, they have to add 180 and so on. So if I go back to, we used what, A, B, and C a minute ago from the triangle, I think? If I go back and I label those out again, I'm going to get rid of some of these extras for a second. This is A, B, C. We'll call this exterior 1. What do angles A, B, and C have to add up to equal? What do angles A and F have to add up to equal? So they add up the same thing, don't they? I know, it's crazy. So watch what happens. If you use what's called the triangle sum, I'll write that out here again. Sum of the interior angles in a triangle always equals 180. And then the exterior angle, oh, we'll come back to here. Talk about that in a second. Again, what did I say A and F have to equal? 180. If I put F here with C, what would it have to equal? If I put it up there with B, what would it have to equal? Exterior plus an interior is always 180, so that doesn't change. So we'll just use A and F again. Do these two things equal the same thing? Yeah. Those two things they both equal 180. So what happens here is we use this thing called substitution. When two things equal the same thing, you can substitute in one for the other. Since they have this common thing of 180, I can set the angle parts equal to each other. And it kind of gets messy with all the angle symbols. So for this example, for this next line, I'm not going to put my angle symbols. You guys going to be mad at me? Will you get over it? Will you try? Okay, shut up. I just want to get rid of, so this just looks cleaner. Okay, that's the only reason why I got rid of it. What does that say about, what can you do that? What's that? Oh, if I add, I can't add it. If I subtract it, what happens to the A's? They go away, right? So that means the A's would drop out. You get B plus C equals F, right? Now, if I look at my diagram, what's that? Oh. So what happens here is no matter where you put an exterior angle, that outside angle will always equal the sum of the two it doesn't touch. What I mean by it doesn't touch, see how it touches angle A? It doesn't touch B or C. Okay. So that outside angle, that exterior angle, will always equal the sum of the two angles it does not touch. Always, always, always. The outside angle always equals the sum of the two it doesn't touch. What does sum mean in math again? You just have to. And this would have worked if I would have placed it here. This would have equaled the sum of those two because the C's would drop out if you did the algebra and so on and so on and so on. It works. What's that? Yep, yep, yep. Yeah, it's super easy once you get going. Just remember that if you're an angle on the outside, you equal the sum of the two you don't touch. That's really all there is to it. You remember that? They're heavy. It's pretty quick. For example, oh, got out of sequence here. Sorry. For example, if I look at that, the triangle on the left there, it's asking us to figure out what angle 1 is. Is angle 1 on the outside or the inside of the triangle? It's the outside. I guess the opposite. If I'm looking at this, I know that angle 1 is on the outside. It has to equal the sum of the two it doesn't touch. What doesn't it touch? What's 18 plus 80? It's 98. Okay. The angle on the outside equals the sum of the two it doesn't touch. Reason is, if I walked into the inside here, and I needed to figure out what this angle was to start with, I would have taken 180, subtracted the 98, because that's what these two add up to equal. Back that out, you get what, 82? Oops. And then again, those two have to add up to equal a line. And the supplement to 82 is that 98. There are many, many ways about going about doing these problems. But if you remember, the outside angle equals the sum of the two it doesn't touch. What are you going to do with the one on the right? Yeah, exactly. You guys heard him? Since you already have the outside angle, you know one of the insides, you just got to subtract it. So the outside angle is 59 plus something. I didn't want to write 2 there just because somebody will write 61. So one-step equation, just subtract 59 from both sides. And what do you get? Yep. And again, you could go the long way if you wanted to. Supplement to come into here. What was that? 56, I believe. 56 and 59 is 115. Subtract that from 180 and you get 65. It's a shortcut from having to do it. It's just a shortcut of the algebra. The outside angle equals the sum of the two it doesn't touch. Okay? Which means then we can do bigger pictures. Problems that have just numbers. Problems that have variables. Problems that have algebra. Because it only is these two rules that we're working with today. Which will allow you to figure out angles X, Y, and Z. Take a second and try to figure it out. I'll let you try to do it. Please and thank you. A lot of times with these things, people, there's like 4 or 5 different ways of going about a problem like this. It does not matter where you start to try to figure out what you want to do. The only one, there's really, you can start anywhere to figure it out. In my head, I start with X. Reason being, if you look at the picture, that right there is a triangle. You know 2 of the 3 angles in the triangle, which means what do you do to find the third? You just, add them and subtract them. So take your 180, subtract out, what, 43 and 59 is what? 112, thank you. Yeah, you had too many zeros, too many 10s there. 102. Okay. Subtract that out, and you should get what? 78, right? What's that? It's 102. Okay. That means angle X and angle Y, if you look at it, they create a line. Which means they have to add up to equal. So 78 and what is 180? 102. Because isn't angle Y the exterior angle of those two? So it has to equal the sum of the two it doesn't touch. Okay? And then that gets you to angle C. You've got your 49 and your 102. That gives you 151. How much is left then for C? Yes, sir.
So the reason why it's 120 is because of the exterior of that triangle.
It's not 120, 102. Oh, yeah. It is, but also remember, if you get 78 here for X, 78 plus what creates a line? They're supplementary. They're next to each other. They're a linear pair. Or if you saw it differently, exterior angle, you've got the 2 that it doesn't touch. It has to equal the sum of the 2 it doesn't touch. Either way, it's fine. It works. Math is going to math. All right, subtract that one out. What is it? 29 then, I think? You're looking at a big picture, figuring out where to start, and just start backing things out. There's only 2 rules you have. Angles in a triangle add up to 180. Exterior angle is equal to 2 it doesn't touch. Okay. What's that? We did. 51. Sometimes the problem will ask you to solve for x. Sometimes the problem will ask you to solve for the exterior angle. I just cut off the instructions on that one, just didn't solve for x. This one, let's figure out what the exterior angle is equal to. Okay. Same idea. As you're going through these, remember that you are working with, excuse me, you're working with an exterior angle. The exterior angle always adds up, or excuse me, always equals the sum of the two it does not touch. So, as you write this out, you should be doing this. The outside angle equals the sum of the two it doesn't touch. Combine your like terms. And then start moving things around. Subtract 2x from both sides. At the same time, I'm going to subtract 8. What's that? Outside. The outside angle. Yeah, it'll tell you what to do. Was it 54 subtract 8 is what? 46? And half of 46 is? Okay. Now, if I wanted to figure out what that outside angle is, I have to do 4 times 26. Well, it's really easy to do that in your head. If you double 46, excuse me, if you double 23, I'll say it right eventually. What did you get? 46. Double 46, and you get 92. Add 8 to that, and you get 100. The outside angle here would equal 100 degrees. Yeah, the one it touches. Yeah, the other one it touches would be 80, and then the 2x plus 23 has to be 49, because if you think about it, 51 plus what is 100? So if it doesn't equal 49, you screwed up. All right. Here, do this one real quick. I want to watch it. Sure. Why not? Same idea, guys. Same idea. This stuff does not change very all that often when it comes down to some of these things. And hopefully you start to find the patterns and how things work themselves through. How are you getting negative? Should you be getting negative? Shouldn't have negative angles. Outside angle is equal to the sum. Enough! Guys, enough. When you combine like terms on the one side, you get x, not 3x. And now you subtract the x from both sides and add 7. Divide that out, and you get what? 2. Guys, I think I've made mention of this a couple of times. The dumb mistakes you guys are making algebraically is this right here. You're trying to do this, going, oh, I'm going to add x to here. You can't do that, guys. You only add to both sides of an equation. When it's on the same side, you just combine them. It's 2 minus 1 is all you had to figure out there. Okay? I see that all the time. So please stop. Pretty please. Don't ask for much. Just stop doing that. But then obviously if you had to substitute in, you can substitute in. It's pretty quick and easy. To be honest with you, other than that, these are pretty quick. We really don't think we need to waste our time with this another day. So we need a little bit of time. These are in the textbook. You pull this up now, screenshot it. You got a good 10, 11 minutes. Most people are getting 90% of it done in about 10 minutes. It's that fast. Okay? Please get started. If you don't have your Chromebook or you just want to take a screenshot of it, I have the textbook right here. If you want to take a picture, I'm fine with that. But, gentlemen and ladies, this means it's time to work, not sit around and. Exactly.